So hello everyone, my name is Klaus, and just as the previous speaker, I get a lot of data from people who have maybe not spent a lot of time worrying about the quality of the way to present your data. So I will try to give you a tale of frustration and beer. It's not about Brussels, but it does include a bit of statistics and some R. So let me start by telling you about a project I'm involved in. It's called the Rescue Project. It's a way to analyze the effect of alcohol use disorder treatment in Denmark. So there's a certain program. If you have a person who would like to enter this program because he or she has an alcohol use disorder, they follow this program, but they actually don't know if it's working in the end. So do they reduce the amount of alcohol intake that person gets after, say, half a year or a year? So that's the entry point for this. So let me show you some data that I was presented with. So one way to register how much a person drinks is a measure called the timeline follow back. So essentially what they're asking is that the client or the patient, how much alcohol did you drink yesterday? So that's recorded in the day 1 column, and the day before yesterday, that's day 2, and so forth, back for 30 days. So for the last month, they believe that people can remember how much they drank individually on each specific day. So that's the data that you can see here. So that's for individuals, for rows, and we just show for 3 days. And some of the information here is missing. And at this point, I was asking the client that gave me this data, the missing data, I suppose that's just a 0, right? I should put in a 0. And then they said, no. You shouldn't put in a 0, because the missing means that the person didn't want to write the same number as the previous day, because people have a drinking pattern. So the first person who had 14 alcohol units for the first day is also drinking 14 alcohol units on the second day and 14 on the third day. So you should just repeat the previous number that you have available. Right, so I did that. That's fairly simple. Then there's a number 99. And I asked them, did we really have a person who drank 99 alcohol units on a single day? And they said, no, 99, that's missing. So because obviously no one will drink 99 alcohol units for a single day, so that's a missing value, so you should replace that with missing. And I did that. So if we look further down the numbers, there's an 88. That's another type of missing. So at this point, I became quite frustrated, because I know that doing analysis and data science is an iterative process where we talk to the client because they know stuff about what we're actually handling, and it's not just numbers. But this is silly for me to go back every time and look at that. So I decided to do some tests for myself. And here is a plot with it. Each single dot here is an individual. So that's the total number of alcohol units, drinks, essentially, that person had for the last month. And you can clearly see that there's an outlier here. There's a person who had almost 1,200 alcohol units in 30 months period. And that is not an error. That's not an outlier, which I believed it was, but I had to go back to the client and say, well, that's actually true. So that person had 40 drinks per day on average for the last 30. So the message to get out of this is I can do a lot of checks based on my layman's knowledge of whatever I'm looking at, but I need someone with knowledge about the context to be able to find the real errors. So that started giving me some worries about what are we actually not finding in the data sets. So I know we can put in validation checks, and as Pete just showed in the previous talk, you could have ranges for validations and all that stuff. All the stuff we know what we should be checking for, that is easy if we can get someone to write down all the code. The problem is, what about all the errors that we are not able to find? And that means including, for example, that center that we had, where they decided midway through the study that day 1 was probably 30 days ago and not yesterday. So they swapped the whole time axis the rest of the individuals. And the only way to notice that was because someone with knowledge about how the profile should actually look, what was supposed to be. So we need some experts in the relevant fields to check the data for us, or at least in combination with us. Usually they don't have a lot of coding skills or R skills or whatever, so we need to help them or work in some kind of collaboration. And this is especially crucial because it's becoming more and more common for large-scale collaborations where you want to include data sets that are almost similar from different countries, for example, to get enough sample size to have a power to detect small changes. And if we don't know what kind of checks that we did and the other people did, then we don't really know if we are combining data that should be combined, or if we need to do some other kind of checks. And also, when we get new technologies available, biotechnology, for example, some of the old data sets that were useful 30 years ago will get a new life because we are able to use them in other venues. And if we don't remember what we did 30 years ago, and I don't remember what I did 2 weeks ago, then we need to have some kind of documentation about what we actually did. So let me try to show you an R package that tries to handle some of this for you. So here is a toy data set. There are different types of variables, as you can see. Some are text strings, some are integers, numeric factors, and so forth. So this is a toy input data that I would like to check for errors, or at least standardize my checks for errors. So the package that we have been developing is called DataMade. It's made for cleaning data. And essentially, you only need to use one line of code. And we actually also have a Shiny web server where you can run it if you don't want to enter things into R by yourself. But that's the clean function. So the clean function takes your data frame or tuple and produces an HTML file or a PDF file that you can hand over to your client and say, look at this. Does that make sense based on what you have in your data set? So the flowchart for what is going on is essentially like this. So we have a data frame or tuple. Then for each column in the data frame, we have a set of a battery of summary functions, and then a battery of visualization functions and a battery of check functions. And we go through each column in the data frame, produce an R Markdown file that is rendered in the end and can be passed on. So let me show you how that actually looks. And I think we have time to look at the actual output. So here we have it. So that's the output that we get from from analyzing this toy data set. So first we get a standard summary with the number of columns and the number of rows. We get information about what types of checks that were run for different types of input variables. So if you have factors, for example, you will run these checks by default in the package. And we get a small summary of the variables that are in the data set. All of that is super standard and not that exciting. Let's see if we can go. But then for each variable, we get some information about that particular variable that we can hand over to the client. So for example, the first one here, color, that's a factor. We get the amount of missing that is found for that particular variable, the number of unique values, and some kind of plot for a factor. We get a bar plot like you see here. And if some of the checks detect that there could be a potential error, it will write the notes at the end of this summary here. So these are not all the checks, but these are just points for the clients to be aware of. For example, here we have that the blue level category is only present in 5 or fewer observations. Is that true? So it doesn't do anything, it just raises a thing and say, are you aware of this? Here, for example, for the integer variable, it changes the summary, so we get the minimum and the maximum because it's a numeric variable, and it also tells us there's a value here, 999. Is that supposed to be a missing variable or not? And we have a NaN. Is that supposed to be a missing variable? And so forth. And does outlier detection, super simple, nothing complicated, and says, okay, there's also a value 82 here. Maybe that's an outlier, and you should go and check for that. So that's the whole idea, to go through each of the variables in the data set. And for example, if you have things like a string or a character, here there is some encoding problems. There's a factor level. Essentially, it's the same problem as Pete just mentioned. We have one level called other with the lower letters, and another level called other with uppercase letters. Is that the same or isn't that the same? So it tries to detect if there's some kind of obvious collapsibility in the factor levels that you should be aware of. And as I said, it doesn't do anything besides producing the report. It doesn't fix your data, because that should be done by a human being and not a computer. But it tries to run through all these standard built-in tests. Let's go back to this one here. The functions included in the package can also be run interactively. So if you don't want to generate the full R Markdown file, you can just check a particular variable, for example, and you will get a list containing the same information that is being printed in the summary output. So if you want to use it in your own framework for presenting data for your client, it's actually possible to do that directly. So there's a standard battery of tests that are included in the package. What is what's mostly interesting, I think, is that it's actually possible to extend it by providing your own checks that will become part of the standard battery. So if I have a lot of collaboration with my client that wants to write missing values as 99, for example, I could make a specific check that I would include whenever I have that client. And if I see variables where I have a 99 that is completely outside the range of everything else, I would be aware of that. Yeah, let me just show you how to do that. So here's an example for where I want to make sure that I don't print private data. So sometimes I get handed data with individual social security number IDs. So everyone in Denmark has a social security number, or the corresponding version of the social security number, and those are private, and you're not allowed to actually keep them in data sets where people can see them and stuff like that. So I should be critical if a client gives me a data set where there are those social security numbers. So here is a simple function that actually checks for a format for the US social security numbers with 3 digits, a dash, 2 digits, and then 4 digits. And if I have variables where I detect that, then I print out that, hey, you should be aware that this is potentially bad and we should not distribute those data to someone else. And I can add that function to my battery of checks just by specifying that for characters, and you can see that at the bottom here, for characters I would like to include that particular check as well on top of all the other checks. Right, so to conclude, we are sort of geeks and nerds. Everyone knows that 42 is the answer to the question of life, the universe, and everything. So, as Douglas Adams pointed out in his book, what they did after finding the answer was that they decided to build a computer to figure out what was the question. And that's exactly what we're doing here, essentially, because we need to figure out what did we actually check in all the previous steps that we did in part of exploratory data analysis and all of that. We need to have that documented. I'm just about done, Jonathan, so yeah. So we need to have that documented in some way. And one possibility is to use packages like the Codebooker or DataMate to keep that documentation contained somewhere and be able to use that as a collaborative tool with your potential clients. And remember, you're your worst collaborator. You cannot remember what you did 2 years ago or 5 years ago. Thanks.
Thank you. We do have time for a question or two.
Can I use it with data format? With date formats? Yes. So it actually handles dates as well. Yeah.
Do you also have multivariates checked? Because I have the impression that most were univariate.
I couldn't hear that. Yeah, no, so you're completely right. So it works column by column. So essentially, if you have Y data, and my data were actually Y data, where I had a profile for each individual, it doesn't do that right now. So we're trying to make some standard tests for that, but it's very hard to make a standard for something that is multivariate, because that's different from a case-to-case basis. Yeah.
So have you begun to think through, when you have a table that's 3,000 columns wide, currently you're writing out a report, have you thought about how you don't overload the user?
So how will I not overload the user by having a large data set and making a printout? I don't know. So actually for the alcohol data set here, we produced a PDF file with 1,800 pages. And we were quite happy about it. I'm pretty sure that the client was not quite as happy about it as we were.
Okay, if we can thank the speaker, please.